Howdy, students. Dan here. Just wanted to give you a couple of quick tips to answer a common question for integration by parts. So, in general, for integration by parts, let's say, for example, we have, say, x squared sine of 2x dx. Okay, so if we need to evaluate this, obviously we've got two functions, x squared and sine of 2x, and we need to pick which one of them we're going to call our u and which one we're going to call our dv. So remember, whichever one we call u, we're going to end up taking its derivative to get du. However, whichever one we call dv, we have to take its integral to get v. So the real sort of how do you pick, the only real guidance is that you want the u to get easier and you want your v not to get harder. So in general, if I were to pick this sine of 2x for my u, then my du is still going to be sine of 2x, and that didn't get easier. Versus x squared is going to become an x cubed, and that got harder. Why would I do that? So instead, I want to pick my u as my x squared, and then my du becomes 2x dx. That got easier. Okay, so then that means that I should pick my sine 2x for that, and then the integral of that is going to be negative 1/2 cosine 2x this way. All right, so then from that, I can simply follow the formula. U times v minus integral of v du. So I just plug in from my four things in the vis. Parentheses are your friend. And also watch the signs that you get your signs correct. So in this problem, u is x squared, v is negative 1/2 cosine 2x. So I did a teeny bit of simplifying, minus the integral of v. So minus cancels that. I can bring my 1/2 out front, cosine 2x dx, and then du was 2. I can bring that out front. Those will cancel and give me a 1 and an x. So we have u v minus a negative here, integral of v du. And I simplified, and then you would be expected to figure out what that integral was. Notice in this particular case, this is another integration by parts, which again, I want to make the choice of u being as simple as I can get, dv to be something that doesn't get too much harder. So then this part, luckily I just have a 1 out front. This is a part where parentheses are your friend, is that if you have a number here like 1/2, it has to multiply all of that. So if you have to do another UDV, then it's in here. So I've got the first part, plus from here, and now I've got my new u and v. So this is going to be x over 2 sine 2x minus, and this is where really parentheses are your friend, because normally we don't have a plus here, we have a minus here, so then we have another minus and we need to distribute, but the integral of v du. And then this final integral we can calculate as being another 1/2 negative cosine of 2x. So final answer here, negative x squared over 2 cosine 2x plus x over 2 sine 2x minus a negative gives me plus a half times a half gives me a fourth cosine 2x plus a constant c. And the big one is that we should take the derivative of this and check that it goes all the way back up to what we started with. Okay, a couple other real quick tips. Don't be fooled on things that look like they would be integration by parts but are easier the other way. So like say integration of sine cubed x dx can be written as the integral of sine of x times the sine squared of x dx. And now we have a product, so we'd be tempted to use integration by parts, but this can also be written as the integral of sine of x times, and then sine squared is actually 1 minus cosine squared x dx, and then I can let u equal cosine and negative du will equal sine of x. Okay, so that one's actually just a u du substitution hidden inside. It's probably easier to solve it that way rather than the other way around. Sometimes it doesn't matter, and don't forget sometimes we have to go around the thing twice, so some of this is just trial and error. But if we have the integral of, say, sine of x e to the x dx, in this particular case it won't end up mattering which one you choose. You'll have to go around the loop twice and then solve for it. So that can happen. Anyway, I hope that helps. Let me know if you have questions. See you in recitation.